Alright guys, so today we are talking about equivalent fractions. So this is just a printout of the anchor chart that you'll find on the wall in our classroom. So equivalent fractions, equivalent just means equal. So when we're talking about equivalent fractions, we're talking about fractions that are equal to each other, okay? So in this first example you see here, one way to find equivalent fractions, so let's say we were trying to find the equivalent fractions to 1/4. So I started by taking 2 and multiplying 2 by both the numerator and denominator. So you can see here I have a green line that is showing you where I multiplied by 2, and by multiplying the numerator and denominator by 2 I ended up with 2/8, which is an equivalent fraction to 1/4. And then I did the same thing with 3. I multiplied both sides by 3, or the top and bottom by 3, and I got 3/12. And then I continued, and these are all equivalent fractions to 1/4. So these fractions are all equivalent to each other. And all I did was multiply the numerator and denominator by the same number. You can pick any number to multiply the numerator and denominator by, as long as you make sure you multiply the same number by the numerator and denominator, you'll end up with an equivalent fraction, as you see here. So I'm going to show you how I know that. How do I know? So when you draw it out, this is a picture of a rectangle cut into 4 pieces, because 4 is our denominator, 1 is our numerator, 1 is what gets filled in, because we know the numerator is the number or parts that are counted, and our denominator is the number of parts in the whole. Okay, so 4 is the number of parts in the whole, and 1 is the number of parts counted. Here we have the same size rectangle cut into 8 parts, and then 2 are shaded in because our fraction is 2/8. But as you can see, it's the same amount. And you can see that with all of these examples. This rectangle is cut into 12 pieces, and 3 are shaded in to represent 3/12, but it's still the same amount. So all of these fractions are equivalent to each other. So they're the same amount. Think of it as a pizza or a cake or anything that you might want to eat. 1/4 of the cake is the same as 2/8 of the cake, and 3/12 of the cake is the same as 4/16. So if you imagine it as food, sometimes we all have an easier time just thinking about it as food rather than just rectangles filled in. So I hope that makes a little bit of sense to you. This is going to be up on the wall for you during this entire unit, so I just wanted to go through that first. But now let's look at our first example. So let's say we wanted to find all the equivalent fractions of 1/3. So all you have to do is multiply both the numerator and denominator by the same number. You can start with 2 and then go to 3 and 4 and 5 like I did in my last example, or you can really pick any numbers that you want. So I am going to start with 2 just to keep it simple in the beginning. So I'm going to multiply both sides by 2, and I will end up with 2/6. Now 2/6 is an equivalent fraction to 1/3. And then we can keep going even. So then we've done 2, so let's do 3 next. I'm going to multiply both sides by 3. 1 times 3 is 3, and 3 times 3 is 9. So 3/9 is also an equivalent fraction, and you can keep going and going all the way up to, I mean, there's infinity numbers of equivalent fractions. 1 times 4 is 4, and 3 times 4 is 12. So you can see that this is one way that you can find equivalent fractions. We're going to try the same thing with 2/7, but instead of going with just 2 and then 3 and then 4, let's just try it with any number we want. So let's go with 7. I want to multiply both sides by 7. 2 times 7 is 14, and 7 times 7 is 49. 49 is an equivalent fraction to 2/7. Okay, and then you can do another number, anything you want. Let's go with 50. Let's do 50. 2 times 50 is 100, and 7 times 50 is 350. So 100 350ths is an equivalent fraction to 2/7. We can go simple again and just do 5. 2 times 5 is 10, and 7 times 5 is 35. So that is also an equivalent fraction. All right, so you can do this with any number you want. As long as you're multiplying both the numerator and denominator by the same number, you will end up with an equivalent fraction. All right, so let's go ahead and look at something that looks like this. So if you were asked to find 4 equivalent fractions that are equal to 2/3, you would basically just do what we just did. So start with 2/3. That's our base fraction. And then we want to find 4 equivalent fractions to 2/3, okay? And they all are going to equal to each other because they're all equivalent. So I'm going to put equal signs in between them. So to start, again, you can start with 2. You can start with any number you want. I'm going to start with 2. 2 times 2 is 4, and 3 times 2 is 6. And then I'll go to 3. I'm just going to write the multiplication out here on the side so I keep track of what I'm doing. 3 times 3 is 9, and 2 times 3 is 6. That's an equivalent fraction. For this one, I'll do 4. Just go right in order. 2 times 4 is 8, and 3 times 4 is 12. And then for the last one, I'll just do 5. 2 times 5 is 10, and 3 times 5 is 15. So these fractions are all equivalent to each other, and this is the answer to this question. So again, we want to define 4 equivalent fractions equal to 2/3, and these are all equivalent fractions equal to 2/3. All right, so another question you may be asked is something like this. Continue the pattern of equivalent fractions. You actually did that on your homework last night. So here we have 2/3, which is equal to 4/6. I can tell that because we're multiplying by 2 on both sides. 2 times 2 gives you 4, and 3 times 2 gives you 6. And then 8/12 because 2 times 4 gives you 8, and 3 times 4 gives you 12. So now we just need to continue that pattern. As we can see, we're going up by 2s. 2, 4. So the next multiplication we're going to want to do is 6. 2 times 6 is 12. And 3 times 6 is 18. 2, 4, 6. Now we're going to multiply by 8. 2 times 8, 16. 3 times 8 is, 24. All right, 2, 4, 6, 8. And the last one we'll multiply by 10. 2 times 10 is 20. And 3 times 10 is 30. So this follows the pattern because as we saw, it went 2 times 2 is 4, and then 2 times 4 is 8, 2 times 6 is 12, 2 times 8 is 16, 2 times 10 is 20. So we just really increased the number we were multiplying by 2, and that kept the pattern going. Okay? So the next problem you may be presented with, and I know this is found on MobyMax, so this is definitely going to come in handy whether you've done it already and maybe you didn't understand it, or if you haven't gotten there yet, this will be really helpful for you. So you may be given a line of equivalent fractions, but with only certain parts missing. So what you have to do is kind of be a detective and figure out, how to figure out what goes in those missing parts. So we have 2/3 to start, and the next one is 4 over blank. We don't really know what it is yet. So the first thing you want to do is say to yourself, well, how do I get from 2 to 4 using either multiplication or division? In this case, we can see that the numerator is getting larger, so it has to be multiplication. So 2 times what gives me 4? Well, if you know your facts, which you all should, it would be 2. 2 times 2 gives you 4. So then you just have to do the same thing on the bottom, right? The rule of equivalent fractions, multiply both sides by the same number. So if we do 3 times 2 down here, we would get 6 for our missing number. Okay, so then we move on to the next step. Taking our first fraction, remember, don't go from the next fraction from the second fraction to the next one. You want to go all the way back to your base fraction. So using our base fraction, 3 times what gives me 9? We should know that that's 3, so then we do the same thing on the top. 2 times 3 is 6. So 6 is our missing number here. And now to find the last one, again, we go back to our base fraction. 3, oops, sorry, we have, that's our empty space. 2 times what gives us 8? Well, that would be 4. So then we have to do the same thing down here on the bottom. 3 times 4 is 12. So 12 would be the missing number. So basically, you just always make sure you go back to that base fraction in order to multiply to get your numerator and denominator. All right, so I hope this was helpful for you. Go back and rewind if you need any further explanation on anything, or you can always ask me, of course, if you have any questions. So good luck.